going to define the break, which is nothing but one more input to the fuzzy logic controller like this. So let's try to see how we are going to implement this. So break also we are going to apply first membership as low break, which ranges from 0. -0.4 to 0.4. Or if you want to change the values, you can change the values like here. I'm taking the minimum value is this much and the maximum value is 0.4. The minimum is 0.4, the maximum value of the membership is -0.42 plus 0.4. Similarly, I'm going to define the second membership with the name as a medium break, and I'm going to define the limits varying from 0.1 to 0.9, and you can see here the name is reliable. Now try to define membership 3 as a high breaking. You are going to apply high breaking as an input. You can see it ranges from 0.6 to 1.4. Like this, I define at input 3 membership. One is low throttle, medium throttle and high throttle. Similarly, one more input I defined with low braking, medium braking and high braking. So now I want to define what kind of the driving I need, or how an electric vehicle can automatically select the driving. Either it may be manual or it may be an automatic. So generally you can select manual, but in some sort of advanced electric vehicle, the vehicle itself will take the decision what type of driving you have to select. Let's try to go to the first membership. So for the first type of driving is nothing but normal mode of driving. Second one, you can see here it also ranges from, when you click on this membership, it can show the range -0.4 to plus 0.5. Coming to the second membership, you relabel this as a fast driving, or you can call this as a normal mode of driving, or we can call it as a fast driving, or we call it as simple as sports mode of operation, sports driving, sports mode driving. Coming to the next membership, you can change and you can write down this as a, so already we had written the program for normal driving, sports driving, and little bit higher than the sports, which is nothing but hyper speed mode of driving, which is called hyper mode. So now we defined first input with 3 membership as low throttle, medium throttle and high throttle. Next to define the second input as low braking, medium braking and high braking, and you define what kind of mode the electric vehicle has to select, which is called normal mode of driving, sports mode of driving and hyper mode of driving. So now you have defined all these things. So just come to here, we can see how it can be implemented. So all these are there, and now we have to write down some set of rules. I will show how I'm going to define the rules. So fuzzy input 1 is given, fuzzy input 2 is given, it's undergoing an defuzzification method and is going to give you the output. Let's try to see how this analysis is going to take place. So the starting of the session, it was very clear to understand how these things are going to occur. So I think now you are very clear about the first input is throttle controller, the next input is braking, the next input, the output is nothing but a type of driving, where the driving is normal mode is one type of driving, sports mode is one type of driving, hyper mode is one type of driving. So now you define the fuzzy and you have defined the inputs, and you have defined the knowledge based system as well as fuzzy inference system with the help of some set of rules, and all this fuzzy inference system will give an output where this is called defuzzification method. So now we are going to find how many defuzzification methods are there. First one is called centroid method. You can see here you are having an output membership varying from 0.1 to maximum versus the universal variable. So now you can, for example, I want to find the output is I want to find an defuzzified output. Exact I want to say what is the output. So this red color one way of solving is called centroid method, where this black color one is the estimated output. From this estimated output, I am getting an output by a method which is called centroid method. Coming to the next one, mean of maxima. I think it's very clear to understand. So this is the minimum value and this is the maximum value. The mean of this value, which is nothing but the center value, which is called the mean of maxima. And next one, minimum of maxima. So this is nothing but the maximum value. In this maximum, what is the minimum value, which is nothing but a minimum of maximum value. Next one is called as a maximum of maximum value. So I can call this as a minimum value and this as maximum value. So all this, for example, this is your estimated output, but you don't know what is exact output. For this we are going to apply defuzzification methods by all these 5 methods of solving. The same technology is implemented in this block where this is also has defuzzification methods. Let's try to see how to implement. So coming to here, I am having a low throttle and I am not applying any kind of brake. What the type of driving I have to drive the vehicle? Normal mode. Just click on add rule, the rule is added. Coming to the next rule. So I am trying to drive in medium throttle. I am giving a medium throttle and automatically I am not applying any brake. So what kind of driving it has to exhibit? Sports driving. Next, I'm going to implement a high throttle, maximum acceleration have been given. I'm not applying any brake. What kind of driving you have to go is hyper driving, which is a dangerous speed. Just add the rule. So now you can see here you have 3 memberships at input, 3 memberships at output, and 3 memberships at output. So number of rules you can write down is nothing but 3 square, which is nothing but 9 rules. So now I have been written 3 rules as per my knowledge, where this is called rule based design. So next one, for example, I am accelerating, low acceleration I am giving, and I am applying a low brake, very low throttle and low brake. I can conclude that the vehicle has to drive in normal mode of operation. Just click on add rule. And next one, you can have low throttle, you can go to maximum braking, automatically the vehicle also will drive in. This is a maximum mode of driving. Automatically what kind of mode it will operate? Normal mode. So coming to the next one, so high throttle you are giving, low brake, high throttle you are giving, low braking you are giving. I can say the vehicle can drive in sports mode. High throttle, low braking, the vehicle can be written in hyper mode. Like this you can add the remaining 2 rules also as per your convenience, whatever the rule you feel which is very important. So now we can see here, low throttle, normal mode of operation, medium throttle, sports mode of operation, high throttle, hyper mode of operation. So low throttle, braking is high, also you try to move in normal mode. Why? Throttle is low. So high throttle automatically have to come to the next sports mode or hyper mode. So after adding all the rules, you just close the rules. Let's try to see what is the type of input we are going to give as a throttle, what kind of input we are going to give as a kind of brake, and what kind of output you can have. So you can see here, go to view and just click on rules. So you can have this rule base. So here you can have, I'm going to define the input. So throttle is how much I'm applying? Only 50% throttle I applied. I'm applying a brake of how much? 50% as 0.4, and you can see that the driving mode is 0.5, which is neither a normal mode neither an sports mode. So now I can conclude that this is called defuzzification method, and your vehicle is now driving in 0.5, which is nothing but the sports mode. This is how to implement a fuzzy logic controller. Hope you can see here I have been explained you about the types of method. So this is using the centroid method for defuzzification. So this is how to implement a fuzzy logic controller for an electric vehicle. So this is about how do you implement a fuzzy logic controller for an electric vehicle. Hope you feel that the video is useful for you. Just give a like, share and subscribe. Thank you.